Good morning. We're continuing to look at section 1.6 Goal Seek, and today we're going to look a bit under the hood. Goal Seek uses something called Newton's method, and so we're going to look at that. The idea of looking at it will be to give us some idea when Goal Seek messes up or goes wrong. The idea of Newton's method is if I wanted to find where x squared equals 2, I take a starting point. I start with, say, x equals 1, draw a tangent line. That gives me a second guess, which I then take and draw a second tangent line. That works out very well if I want to do this with a spreadsheet, as long as for any point I can figure out what the slope of that point is. We're going to go over that lightly because we really don't know how to do that yet, but that's part of what we're going to be doing in this course. So I've set up a spreadsheet. This is the unworked worksheets that starts at x squared, starts at 1, and then follows the step of Newton's method. And we see the first guess has an error of 0.5 because the slope of the error is 0.5. So my second guess is going to be 1.5. If I want to look at this visually, I start here, draw a tangent line, draw a new tangent line, and we see at that point our answer is pretty good, that by our second guess, the error is less than 100th. If I keep doing this, the steps wind up being very small, so I can't even tell where the point is different, and I get to the place that I can't see any difference at all. So that's the basic method I'm going to be using. When I do it with a spreadsheet, I have my formulas all set up so that I have an error, a slope, the error divided by the slope, and that gives me a new x, and I just keep repeating that process. So if I start at 1, I'm going to get something that Excel can't tell the difference between it and the square root of 2 after only 4 steps. If I had taken a different starting point, say I had started at 5, it may take me more steps to get there, but again, I'm going to get back to the same answer. I just keep drawing a tangent line and connecting with that. For some places, this won't work as well. The second example shown here is looking at when is e to the x equal to 1, and it takes it a bunch of steps to get there. Nevertheless, it still gets to where you can't tell the error. The error is 2 times 10 to the minus 17th. Thank you.